Next question. The Earth has 24 time zones defined by dividing the Earth into 24 equal longitudinal segments. These are the regions on Earth that have the same standard time. For example, USA and India fall in different time zones, but Sri Lanka and India are in same time zones. Okay? Now, a relation is defined on the set U, which is all the people on Earth, and relation is defined as set of all x, y such that time difference between time zones x and y reside in 6 hours. Okay? Now, first question is you have to check if relation is reflexive, symmetric, and transitive. Okay. Now, relation is defined as set of all x, y such that the time difference between the time zones x and y reside in is 6 hours. So the time difference is 6 hours between x and y. Okay, first we'll check for reflexive. So if you take x comma x, it is both this people or both this person are residing in the same time zone. Okay, so the difference between the time zones will be what? Now this is in if x comma x belongs to R, it is a relation set, then difference between time zones x and x is 0 hours, correct? Because both are in the same time zone, so the difference between them will be 0. Okay, so this is not reflexive. Let's check for the symmetric. Okay, so if x comma y belongs to R, it implies that the difference between the time zones of x and y is 6 hours. So similarly, we can say that difference between the time zones of y and x is 6 hours, correct? So we can say that y comma x belongs to R. So we can say that R is symmetric. Okay. Next, we'll check for transitivity. Okay. So if say x comma y belongs to R, then we can say that the difference between the time zone of x and y is 6 hours. Okay, and we are taking x comma y and also y comma z, correct? So difference between the time zone of y and z is 6 hours. Now we have to see for x and z. Now x and y, it was 6 hours, and from y to z it was 6 hours. So from x to z it will be 12 hours, correct? So we can say that difference between the time zones of x and z 12 hours. So it is not transitive. Okay. Next question is if R, that is a relation set x comma y such that x and y reside in the same time zone. They are in the same time zone. Okay. Check reflexive and symmetric. Now reflexive is possible because if you take x comma x, okay, and both reside in same time zone, right? So it is reflexive. What about symmetric? Now x and y reside in same time zone. If x and y, you have to write, okay, x and y belongs to R, which implies x and y reside in same time zone. So we can say that y and x also reside in same time zone. Okay, so we can say that it is symmetric. So always look for the condition which is given. Okay, that you have to use. Next question. A fighter jet of the enemy is flying along the parabolic path 4y equal to x square. So this equation is given, x square equal to 4y. Okay. A soldier is located at the point 0, 5 and is aiming to shoot down the jet when it is nearest to him. Okay. So first question is, let xy be the position of the jet at any instant. Express the distance between soldier and the jet as the function of fx. Okay. Now here they have given a parabola. Okay, equation of a parabola. So looking at the equation, you can say that this is a upward parabola, right? X square equal to 2ay. So 2 into 2y, like this. So the soldier, this is the path which is followed by the jet. Okay, soldier is located at some point 0, 5. Okay, so is aiming to shoot down the jet when it is nearest to him. So question is, xy be the position of the jet. So anywhere here, xy is the position of the jet. We have to express the distance between the soldier and the jet as the function of fx. So distance we have to find. So you can use here distance formula. Okay. So let position of the jet be x comma y. Now here equation is given, so you can write y in terms of x, that is y is equal to x square by 4, right? So we can write this as x comma x square by 4. Okay. Now we have the point of jet and the soldier, that is 0, 5. You have to find the distance. So using distance formula, root of x minus 0 the whole square plus y2 minus y1, x2 minus x1. So I will take this. Okay, so this is the distance. Now second, so this distance is your f of x function. Okay. Now taking s equal to f of x the whole square, that is we have to square this distance. Okay. Find ds by dx. That is you have to derivate this with respect to x. Derivating ds s with respect to x. So d square means this root will go. Okay. So we get the function as, I'll write it as okay. Now derivating with respect to x, 2x plus 2 times x square by 4 minus 5, then the derivative of x square by 4, which is 2x by 4. Okay. So 2x, then you can take this x inside, so you'll get plus x cubed by 4 minus 5x. So minus 5x plus 2x is minus 3x. So this is your ds by dx. Okay. Next question is, what will be the distance between the soldier and the jet at the instant when he shoots it down? Okay, or they have given one more question, that is what will be the position of the jet when the soldier shoots it down. So when he shoots it down, that jet will be nearest to him. Okay, so we have to find the minimum position where that jet is. Okay, so this is function, right? This is the derivative of the function. So derivative we have to put equal to 0. Okay, find out the critical points. Okay, let's write that. So ds by dx 0, taking common x. So either it is x equal to 0 or x square equal to 12. So x is equal to root 12. Okay, let's put this. First you have to find this is your ds by dx, that is f dash of x. So we'll find double derivative 3x square upon 4 minus 3. Okay, so we have to check for both the points 0 and root 12. 0 you'll get minus 3, which is less than 0. So this is a point of maximum. 0 is the point of maximum, but we want minima, right? So let's put x equal to root 12. Root 12 square, 9 minus 3, 6, greater than 0. Okay, so root 12 becomes the point of minima. So x equal to root 12. Okay, so this x we have to use. So the point becomes x comma y is x square by 4. So root 12 square by 4. So this is 3. And our x is root 12. Okay, root 12 you can reduce. That is, it is 4 into 3. So this becomes 2 root 3. Okay, so this is the position of the jet when the shoulder shoots it down. This is the nearest point. Okay, so you have to put this point and find the distance, which we have calculated first of all. Because first you write down distance, it was x square plus minus 5. Okay, so x is 2 root 3, that is root 12. Okay, so this is 12 by 4, 3. 5 minus 3, 2. So 4. 12 plus 4, root 16, which is 4. So the distance, minimum distance is 4. Okay. Next question. A balloon is being inflated with the help of an air pump and it remains spherical. Its radius, the surface area, and the volume of air in it are all increasing. Okay, now this is based on our application of derivatives. Okay, so here rate of change is shown, that is a balloon is being inflated, and the question is, are the quantities radius, surface area and volume of the spherical balloon changing at the same rate or different rates when air is filled in it. Okay, so first we'll write, now whenever the balloon is that is it is inflated, its volume is changing, right? And also the surface area is changing. This is our sphere, right? So its volume of the sphere is given by 4 by 3 pi r cube, and its surface area or A is given by 4 pi r square. Okay, now when it's changing, when you it is changing with respect to time. Okay, when it is increasing, that is positive value, will be 4 by 3 into 3 r square, that is the derivative of r cube, and then dr by dt. Okay, now here when volume is changing, its radius is also changing, but you can't say that it is changing at the same rate. Okay, it can be anything. So it is changing but at different rates. Also for the surface area, if you are taking ds by dt, change in the area with respect to t to r dr by dt. Here also its radius is changing and surface area is also changing but at different rates. Okay. Now second is write expressions for the surface area and volume of the balloon at any time t in terms of radius r at that instant. So this is the volume, this is the surface area. At the instant when the radius of the balloon is 6 cm, the radius r is increasing at the rate of 2 cm per second. Find at what rate the surface area as of the balloon is increasing. Okay. So here we have to find the increase in the surface area. So what is given? Radius of the balloon is given. Then radius is increasing at the rate. So rate of increase of radius with respect to time is given. Okay. Now what is the surface area? 4 pi r square. Differentiating with respect to time to r dr by dt. Now you have to substitute the values. R is 6, dr by dt is 2. Okay. 24 into 4. 96. 96 pi. This is change of area. So centimeter square per second. Okay. Next is at the instant when the radius of the balloon is 6 centimeter and radius r is increasing at the rate of 2 centimeter per second. At what rate the volume V of the spherical balloon is increasing. So change in volume. Volume is 4 by 3 pi r cube. Okay. So dV by dt pi 3 r square dr by dt. So substitute values. R square 6 square 36. dr by dt is 2. So this is 36 into 8. 288 pi volume. So centimeter cube per second. Okay. Next question. An octagonal prism is a 3D polyhedron bounded by 2 octagonal bases and 8 rectangular side faces. It has 24 edges and 16 vertices. The prism is rolled along the rectangular faces and number on the bottom face touching the ground is noted. Now let X denote the number obtained on the bottom face and the following table give the probability distribution. Now this information has nothing to do with this problem. Okay, they have only collected the data and now we have to find the probability. They have given the probability based question. Okay, now here the probability distribution table is given. You have to find a value of P. Okay, now to find the value of P, this is probability distribution table. You have to add all the probabilities. So the event, the probabilities will be adding up to 1, right? So adding all the probabilities, you will get plus 2P plus P square plus P square 2P square plus P equal to 1 because total probability is 1. Okay. Now this is 4, 6, 8, 9, 1, 3, 10 and minus 1. So this is 10p square plus 9p minus 1 equal to 0. Okay. Factorization method. Ten p plus 1. So this is p equal to 1 by 10 or p equal to minus 1. So p can't be a negative number. So we have to go for 1 upon 10. Okay. So p is 1 upon 10. Now you have to find the probability where x is greater than 6. So greater than 6, 7 and 8 are there. So p of 7, 8. It is when p x is 7, x is 8. Okay. 2p square plus 7p square plus p. So this is p you can substitute. 1 upon 10. So you can make it 100 by multiplying 10. Okay. Next is x is equal to 3m where m is a natural number. So m we can put values 1, 2, 3 and so on. Okay. When m is equal to 1, this will be x equal to 3. When m is equal to 2, this will be 6, right? When m is equal to 3, this will be 9. But 9 is not there. So only 2. X equal to 3 to p. X equal to 6 p square. So substituting value of p, 20 upon 100 plus 1 upon 100. So 21 by 100. Okay, 0.21. Next, find the mean. So mean, how it is given? You have to multiply the number and the probability. Okay. So this is 1 into P plus 2 into 2P plus 3 into 2P plus 4 into P 5 into 2P 6P square 7 to the 14 56P square plus 8P. Okay, so this is P, this is 4P 6P 4 10. Okay, 5 11 15 25 33 then 6 20 76. Okay, once again I'll add 5 11 15 25 33. Okay, 20 66 76. Okay, so substituting value of P. Okay, here we can multiply 10. So 330 plus 76. 406 divided by 100. 4.06. Okay. Next question. A tank formed using a combination of a cylinder and a cone. Okay. Here cylinder is there and there is a cone. So this is a tank. Now offer better drainage as compared to a flat bottom tank. A tap is connected to such a tank whose conical part is full of water. Okay, this part is full of water. Now water is dripping out from a tap at the bottom at the uniform rate of 2 centimeter cube per second. Now this volume is decreasing, right? Water is dripping out. So this volume dV by dt you have to take negative minus 2 centimeter cube per second. The semi-vertical angle of the conical tank is 45 degrees. So this angle is 45 degrees. So this will be also 45 degree. And we know that whenever this is 45, this is 45, we take 1 root 2. That is this length is equal to this length. That is this is an isosceles triangle. Okay. So the radius and the height of the cone are same. Okay. Radius and height are same. Now find the volume of the water in the tank in terms of its radius r. Okay. Volume of the water in the tank, they have given that only conical part is full of water. So volume of the cone 1 by 3 pi r square h, and we want it in terms of radius. So in place of h you have to substitute r. Okay, that is h is equal to r, so we can substitute here r. So it will be 1 by 3 pi r cube. Find the rate of change of radius at an instant when r is 2 root 2 centimeter. Now, if you differentiate this, okay, with respect to t, we are given this value, that is minus 2. So we can find dr by dt. Okay, radius is 2 root 2. So differentiate dv by dt. So this is 3 r square dr by dt. Okay. So dv by dt is minus 2. 3 you can cancel. Pi. Our radius is given to root 2. And we have to find dr by dt. Okay. This is square. 1 by 3 pi r cube. So this is, yeah, square. So root 2 into root 2 is 2 minus 1 upon 4 pi. Okay. Change in radius. So this is centimeter per sec. This is your dr by dt. Next, find the rate at which the wet surface of the conical tank is decreasing at an instant when radius r is 2 root 2. Now here they have specified that wet surface means we have to find the decreasing area of that tank, that is the conical part. Okay, so this is in this form, right? So we want only this area, not this one. Okay, wet surface is this, so this becomes our curved surface area. Curved surface area of a cone. Okay, now here slant height is given, but we don't have value of slant height. We can convert this slant height into radius. How? We can take the formula L square h square plus r square. Okay, and we know that r is equal to h. So everything we can convert into r. Okay, so this becomes r square, 2r square. So L is root 2 r. Okay, so L equal to root 2 r. So you can substitute over there. This is your curved surface area. So I will write it as S. So this will be r square. Okay. So change in the surface area. Okay. So radius we have 2 root 2, and we also have a value of dr by dt. So substitute. So the answer is minus 2, and this area is centimeter square per second. Okay. As volume is decreasing, that wet surface is also decreasing. So it is coming minus 2. Okay. Next is you have to find the rate of change of height at an instant when slant height is 4 centimeter. Okay. So we have got the slant height is h square plus r square. Okay. We have to find the rate of change of height with respect to t when L is 4. So when L is 4, we can substitute here 4. R square, R is given, that is 2 root 2. So this becomes 4 into 2, 8. So root 8 is our h. Okay. Now here the thing is r is given equal to h. Okay. So our dr by dt value becomes equal to dh by dt value. That is minus 1 upon 4 pi centimeter per second. Okay. So at L equal to 4, the h value is same. That is dh by dt is same as dr by dt minus 1 upon 4 pi. Okay.